Hello everyone, welcome to the Mathematics in my channel. In this video, we are going to solve this interesting integral from 0 to 1 cube root of x raised to the cube root of x dx. Okay, how to begin? Okay, first we can write this integral is also equal to 0 to 1 x raised to the 1 third x raised to the 1 third dx. Okay, then here we have 1/3, here also 1/3. So we can generalize this integral by taking integral from 0 to 1 x raised to the m times x raised to the n dx. Now we know this is Supermod's dream type integral. As I remember, I create a video about it, the Supermod's dream. Anyway, let's solve this integral. Okay, first of all, we know x is equal to e to the natural log of x. Therefore, here x to the mx to the n, x raised to the mx raised to the n, we can represent as e raised to the mx to the n times natural log of x. Now we know the expansion of e to the x. E to the x is equal to 1 plus x over 1 factorial plus x square over 2 factorial plus so on. Therefore, we can write this is equal to 1 plus mx raised to the n times natural log of x plus then m square times x raised to the 2 times n times natural log square of x over 2 factorial plus m raised to the 3 power x raised to the 3n times natural log raised to the 3 power of x over 3 factorial plus so on. Okay, then I'm going to integrate both sides with respect to x. So we can write integral from 0 to 1 x raised to the mx raised to the n dx is equal to integral from 0 to 1, here 1, so dx plus here m integral from 0 to 1 x to the n times natural log of x plus here m square over 2 factorial integral from 0 to 1 x raised to the 2n times natural log square of x dx, here dx, then again plus m raised to the 3 power over 3 factorial integral from 0 to 1 x raised to the 3 times n times natural log raised to the 3 power of x dx. Well, now if you look at carefully here, these are same type of integrals, so we can generalize these integrals like integral from 0 to 1 x to the a times natural log raised to the b of x dx. Well, let's try to solve this integral. Okay, to evaluate this integral, we can take a substitution. U is equal to minus natural log of x, then we can isolate the x we know, e to the minus u, then we can differentiate. Dx is equal to minus e to the minus u du. Now we can plug in here limit, lower limit when x approaches to 0, we know u approaches to infinity, upper limit x approaches to 1, u approaches to 0, and x we know e to the minus u raised to the a, natural log of x we know minus u, so minus u raised to the b power, and dx we know minus e to the minus u du. Okay, then we can interchange limit 0 to infinity. When we change the limit, this minus sign get cancelled, so we have e to the, here e to the minus u raised to the a power, here e to the minus u, so e to the minus u times a plus 1 times, here we have minus sign, so minus 1 raised to the b power times u to the b power du. Okay, then minus 1 raised to the b constant, so minus 1 to the b outside of the integer sign, and here 0 to infinity e to the minus u times a plus 1 times u to the b du. Okay, now to evaluate this integral, again we can take a substitution. T is equal to u times a plus 1, so we should differentiate. Dt is equal to a plus 1 du. Okay, then we can plug in. So here minus 1 raised to the b power, limit also 0 to infinity. Now here e to the minus u times a plus 1, we know t, so minus t, u we know here u, t over a plus 1, so t to the b over a plus 1 raised to the b power times du, we know here du, dt over a plus 1. Okay, then a plus 1 raised to the b power, a plus 1 constant, so we can take outside of the integer sign, minus 1 to the b over a plus 1 raised to the b plus 1, integral from 0 to infinity e to the minus t times t to the b dt. Now this is familiar with us because we know this is equal to gamma function. So here minus 1 to the b over a plus 1 raised to the b plus 1 times gamma of b plus 1, and gamma of b plus 1 we know b factorial, so minus 1 to the b over a plus 1 raised to the b plus b plus 1, here minus 1 to the b times b factorial. Okay, then we know we evaluate the integral, integral from 0 to 1 x to the a times natural log raised to the b power of x dx is equal to minus 1 to the b power times b factorial over a plus 1 raised to the b plus 1. Okay, then we know our integral here, this part, this line I'm going to rewrite. So integral from 0 to 1 x raised to the mx raised to the n dx is equal to here 0 to 1 dx we know 1 plus m times integral from 0 to 1 x to the n natural log of x dx plus m square over 2 factorial integral from 0 to 1 x to the 2n natural log square of x dx, then again plus m cube over 3 factorial integral from 0 to 1 x raised to the 3n times natural log raised to the 3 power of x dx plus so on. Okay, now we are going to evaluate this integral. So for this integral, here we have n and here we know a, so we know a is equal n, and here b, and here we know 1, so b we know 1. Therefore we know the answer of this integral minus 1 to the b, so we can write okay, if we take our integral 0 to 1 x raised to the mx raised to the n dx is equal to, here we have 1 plus m times, now we know this integral is equal to a is equal and b is equal 1. When b is equal to 1, here minus sign, so here we have minus, so we can write here 1 minus m times here a we know n, so n plus 1, b 1, so n plus 1 perfect square, so m over n plus 1 perfect square. Then for this integral we know a is equal 2 times n, here 2 times n, and here b we know 2. So here we have plus m square over 2 factorial times here minus 1 raised to the 2 power we know plus 1, and b we know 2, so 2 factorial over a we know 2 times n, so 2n plus 1, 2n plus 1 raised to the 3 power. Then according to this pattern we can write here m cube over 3 factorial times 3 factorial over 3n plus 1 raised to the 4 power plus so on. Okay, now our question, integral from 0 to 1 cube root of x raised to the cube root of x dx is equal to, now we know here m and here n, so m is equal 1/3 and n is equal to also 1/3, so we can write 1 minus 1/3 over 1/3 plus 1 perfect square, here 2 factorial get cancelled, then plus m square we know 1/3 square over here 2n plus 1, so 2 over 3 plus 1 raised to the 3 power, then minus 3 factorial get cancelled, here 1/3 cube over 3 over 3 plus 1 raised to the 4th power plus so on. Okay, this is the answer for this integral. If you like this type of videos, please subscribe this channel. Thank you for watching.